Greetings and welcome to this practice WOD on functional programming. We're going to use the underscore library, so hopefully you've gone through that. And to make it kind of more fun, we're going to use this thing called the Hawaii Open Dataset, which has all sorts of data, government data. And in particular, we're going to use this data set that provides 5 years of degree data. Okay, and what I've basically done is I have extracted that into a file that we can use, and the file is actually right here. Okay, so because there's a little bit of hassle in just kind of downloading that data and getting it in a form that can be used easily by JavaScript. So I've done a little work, tiny bit of work to make that easier for you. Okay, so before we even start the WOD, what I want you to do is set up jsfiddle for what you're going to be doing. So let's go to jsfiddle, and you can see where I'm logged in. I guess there's a cookie set someplace. And what we're going to do is we're going to tell jsfiddle that we want to use the underscore library. And the way we do that is by pulling down that menu item, finding underscore, and selecting the latest version, which is 1.8.3. And then to verify that it's actually working, what underscore library does is it defines a new symbol called underscore with a whole bunch of methods associated with it. So there's one that's called identity, which just returns whatever value that it was passed. So to check to see that that the underscore library is loaded, one simple thing to do is just invoke that function and see if everything works. So we can run it and we see yes, the console prints out 1, which is the value returned from the identity function, so we're all good. Okay, so that's what that just does. So the second thing is to take a look at this data set, which looks like this, which is basically an array of objects. Each object has key value pairs which provides data about a year and a campus and a school or whatever, and then how many awards they gave. And then for the purposes of this WOD, if this Hawaiian legacy field says Hawaiian, then that's the number of awards that were given to students of Hawaiian ancestry. We're going to need to know about that in a minute. Okay, so how do we get this into jsfiddle? Well, what you do is you specify it as an external resource. So I'm going to copy this URL, and I'm going to go back to jsfiddle. I'm going to click on the external resources link, and then I'm going to paste this in here, press the plus button, and now we can see that uhdata.js is now an external resource, which means that this uhdata field is going to be defined. How do we test that? Well, what we can do is we can just say something like uhdata since it's an array, we can call the length function, and if we run that, we can see, okay, there's 3,744 elements in that array. Okay, so what's next? Okay, so we get our 3744, so we know that the uhdata field has been added. Okay, so now that we have uhdata and underscore defined, we can start the WOD. So let me go find my application, my time application, get that running. Okay, so what is it that we're actually going to do? We're going to start the timer, I just did that, and we're going to create a variable called testData and set it equal to the first few elements of the uhdata array. So when you're using underscore, you almost for sure want to have this page open because it has the documentation on all these functions that are set up. And it turns out that for the array, okay, there is a a function called first, which returns the first n elements of the array. So we want to set a variable called test data set equal the first few elements of the UH data array. So let's start off by, I'm going to comment that out, and I'm going to say const test data equals to underscore dot first UH data. Let's just say 2. What the heck, to start. And then so that I can inspect this, let's write it out to the console. So if I evaluate this, I get this test data array that's only got 2 elements in it. The first is this object here, which has 69 awards, and the second element is this object here, which has 322 awards. Okay, neither of these sets of awards are associated with Hawaiian students. Okay, so we're going to now implement 2 functions. We can't have a for loop or an if statement. That's kind of a heuristic or rule of thumb that says, oh, if you don't have loops or conditionals, you're probably programming in a functional style. I guess sometimes you could have if statements and maybe be functional. Sometimes you can even have loops, I guess, and be functional, as long as the function as a whole is side effect free. But the whole point is that we want to use the underscore package, which as you see, will eliminate the need for those and thus make our code more concise and easy to understand. Okay, so the first thing is we're going to write a function called total degrees that's passed a data structure, the UH data structure, and will return the total number of degrees awarded in the data set. So for the entire UH data set, the correct answer is like 48,000. Okay, so we're going to write this thing that's going to return the total degrees. How are we going to do that? Well, I think what we want to do first is, if we look at this, it would be nice. We could kind of loop through this thing, but with a for loop and then look for the awards field and so forth. That'd be the standard way to do it. But the functional way is to first say, can we go through this data set and extract these values, right? Because that's what we want to sum up. And we can, and it's called the Pluck function, which is a super useful function. You're going to want to use this all the time when you have a list of objects and you want to get the values of a particular property. So here's a list of objects, and they're going to extract out the value of the name, so we return a new list or new array that's just got the values of the name field. So that's tailor-made for what we want to do. So let's play around with that a little bit. So let's say we could say let degrees equals underscore dot pluck, and then let's use our test data, and the field that we're going to get out of there is called awards. Okay, so do that. Okay, and then let's do a console.log degrees so we can see we can see what's happening here. So this is, I'm trying to show you a way that rather than just kind of write the whole piece of code, and then hope that everything worked okay, we can build it up incrementally. So if I run this, okay, what I see is I return back this array with 2 elements in it, and these are the 2 awards. We just saw that, right? 69 and 322. Okay, so now we've got this array. This function right here is going to return an array with the data items in it. Okay, so that's good. Now, how do we iterate over this array and add up all these elements? And this is going to involve one of the very famous kind of functional operations called reduce, which is to, they say boils down a list of values into a single value. That's exactly what we want to do. And in fact, their example shows the exact thing we want to have happen, which is it takes a list of values and returns the sum of all of them. The way you do this is you've got to define a function with 2 two arguments. One is something that keeps track of how much we've accumulated so far, and then the current value, and then inside you perform this operation to merge however much has been accumulated so far with whatever the new value is, and that's how you boil down this huge list into a single list. And then you got the base condition, which is what happens when you start up. You don't have anything that this function has accumulated, so you give an initial value. In this case, it's 0, so that you can get this final sum. So it turns out actually that this is exactly what we want to use. In fact, we want to use this entire thing here, but we just want to pass in so let's say let degree total equal this reduction call, but instead of 1, 2, 3, we'll use degrees. Okay, and then we can get rid of this, and we'll say console.log degree total. Okay, so if we run this, we get 391, which is exactly what we want. 322 plus 69 is in fact 391. Okay, so we've got all the pieces of this thing. All we really need to do now is combine it together into a function called total degrees and run it over our entire thing. So let's build that function total degrees, which takes data. And then what are we going to do? Well, I'd say the first thing is let's just say we've got to create that array of degree values. So let's make one of those. And then once we have that, we want to return the result of reducing them. Okay, but instead of test data, we want to fix that so that we're actually, whatever data we're passing in is what we send to this. Okay, so let's try this now. Let's say console.log total degrees with test data and see what happens. And I'll just erase this so that it's clear what happens whenever we do this. Okay, we get 391, which is what we had before, which is good. So therefore, if we just say data, we should find out the final answer. So control return 48,186. That's exactly right. Okay, so we got our total degrees done. Yay for us. Second one is percentage Hawaiian data. This function can be passed UH data and returns the percentage of degrees that were awarded to students of Hawaiian legacy in the data set. Such students are indicated by the string Hawaiian in the Hawaiian legacy field. So we can see example of this as the 6th element of that array. So there's that Hawaiian legacy Hawaiian thing. Okay, so so basically what we have to do is we have to find the number of degrees given to everybody. Well, we know that already. That's the total degrees. And then we have to extract from the overall data set those entries in the data set where we have the string Hawaiian in the Hawaiian legacy field and create kind of a reduced data set of all the Hawaiian students, and then we sum that up. Okay? And then we divide the two, and then we get the percentage. So let's see, the first thing we have to figure out is how the heck do we convert this data set into a smaller data set that only includes the students of Hawaiian ancestry. To do that, let's change our test data to be the first 6 elements. Okay, and the reason being is that if we do that, then what you'll see is that we have 5 objects that don't have any degrees of Hawaiian ancestry, but then we have one that does. Okay, So now our test data set, we can actually kind of fiddle around with it and see that we're getting what we want. Okay, so let Hawaiian data equal, and then what's the underscore function that we're going to call? Well, the underscore function that we'll call is called filter, naturally enough, and that one takes a list, which will be our UH data set, and then a predicate. And the predicate is a function that takes an element of the list and returns true if we want that element to be in our resulting list, and returns false if we don't want it in the resulting list. So this just applies this function over all the elements in the past list and tells us whether or not we want to include it. Okay, so that's pretty easy. So what we're going to say is we're going to say filter, and we'll say test data, and then we'll have a function that takes a entry, and it's going to return true if entry, what's it called, Hawaiian legacy? Yeah, Hawaiian underscore legacy. So if the value of that field is equal to Hawaiian. Okay? So that's Hawaiian data. So let's just check to see whether that works the way we'd expect. How do we expect it to work with our test data set? Well, our test data set has 6 elements, one of which is Hawaiian data, so we should only have one element remaining when we run this function. So let's see if that's what actually happens. Okay, so wait, we've got 6 items. We've got 2 items here. Am I wrong? Okay, Hawaiian legacy there, and then Hawaiian legacy. That's interesting. Was I missing one here? Let's see. Okay, so here's no, 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 no. Oh, there it is, 5. Yep, you're right. So, or I was right. Okay, so there's 2 actually that should be returned in this data set because there was 2 in our initial ones. All right, so so it works. Okay, with a little bit of inspection. So that's how we get a data set that has just the Hawaiian data. We already know how to get, and then once we have that that data set, we can now find the number of degrees in that one by using our reduction function, and then we can do a division. So I think we're ready to actually write the function. So let's say function percentage Hawaiian. Okay, so that's going to take data. So the first thing we're going to do is we're going to say we're going to say let all degrees equal total degrees of the data that we pass in. Okay? And then we can say let Hawaiian degrees equal total degrees, but then instead of passing it all of the data, we're going to pass it this filter. So we'll do this, and then it's pass it the data. So we pass the data. So this returns a subset of the objects that are the ones with Hawaiian ancestry, and then that's what we pass into this total degrees function, which we already wrote to get the total number of degrees. So now we have all degrees and Hawaiian degrees. So then let's try, then what we want to do is we want to return Hawaiian degrees divided by all degrees, and since it's a percentage, we've got to say times 100. Okay, and then we can do a console.log of percentage Hawaiian with, let's try it first with our test data. So let's get rid of this, and we can actually, to make this, what I'm going to do is I'm going to start off and actually say, let's just take the first couple, because we know there's no Hawaiians in there. So therefore, it should be 0% for our first one. So let's see what happens. Good. Okay, there was another console.log that was corrupt in there. Okay, so that's nice. Let's go to 5. So we get some percentage. Okay, now we get 2.6%. If we look at the first 5, let's see if that makes sense. This is about 400, 450, still about 450. So we get 12 out of about 450, so that's about 2%, or 24 out of 1,000, right? Okay, so that's good. So our back of the envelope calculation says that this is a reasonable number. So to find out the answer, we just have to run it with data. Oops, could spell it correctly. And we get 18.99, which turns out to be the correct. Okay, so all we have to do now is press the save button to make the URL and stop our timer. So 17:39, so about 18 minutes for this. I did a lot of testing and a lot of fiddling around. Don't worry if you have to kind of cruise through other kinds of underscore functions. Use this as an opportunity to just kind of play around and have fun with this. And I think that when you look at this, it's really amazing. Look at how simple that function is when all is said and done. I think you'll find this underscore library is a tremendous tool for simplifying your manipulation of these data structures, and so have fun. See you soon.